So on vertical layers, these slides are taken from MPAS tutorial. In MPAS and also CPAS, it uses vertical coordinate called smooth terrain following STF hybrid coordinate. So what is it about? Look at the figure first. It compared two things, one with S means smooth, and the other just B means basic. Basic. So one feature is that the vertical layers are smooth, and you will see from this example that, say, along the x-axis, there is some plotting about the terrain. If you use a smooth coordinate, you will see that the terrain is kind of smooth. And if there is no smoothing, the basic one, the terrain data will be represented in a non-smooth way. So you see these variations in details. And then as the MPAS software constructs the vertical layers, then the constructed vertical layers are represented by lines above the lowest line. And you will see that without smoothing, the vertical layers have fine details of up and down. But with smoothing, then you will see that basically the vertical layers are smooth, and both of them are terrain following, which means it is above ground level. Every vertical layers is a complete one without hitting the terrain, and with smoothing, you will see that the STF preserves some features like going ups and downs around mountains for the lower layer, but as it goes up, it's become more and more smooth. And in the upper layer, basically it is as smooth as just a straight lines shown in here. So let me explain the adjectives hybrid. Hybrid means it is like the lower part follows terrains more, but the upper part do not. It follows just geometrical height more. So it is called hybrid. And smoothing is done by some smoothing operators, like one Jimmy has shown you earlier, the Gaussian filter, but here it does not use Gaussian filter. It uses another mathematical techniques to do the smoothing. And how is the hybrid feature done? It is just by an addition. So this one maybe theta. Theta is something we will specify, and then there is an A function times the smoothed terrain data. The A function will control the rate, terrain influences to the height. So the next, and then together it becomes the Z variable, and in CPAS or MPAS, the variable is called Z grid. So the next is a slide showing one step in the MPAS and CPAS workflow, which is called init atmosphere. One step in the init atmosphere is to generate a file called init.nc. And in init.nc, the vertical layers are constructed. And here I show some configuration parameters affecting the construction of vertical layers. And if you search smooth, then you will see whether config smooth surface logical, whether you smooth it or not, if the default is true. And then how many iterations, how many smoothing passes to apply to terrain field. Default is 1, and it is terrain NSM terrain, a config NSM terrain. And then another configuration is the maximum number of smoothing passes for coordinate surfaces, which means the upper surfaces. And the default is more. So these workflows has already been integrated into the mesh generation and real simulation job. And after the jobs are run, you will see the results in the in init.nc and also your output files associated. And this slide is also from MPAS tutorial. And it compares the smoothed vertical coordinates, smoothed here, and then the basic one. And then it compares the cases of using different horizontal resolution, like if resolution grid spacing 15 km, you see this column of plotting. The grid you are using is like this one, the upper row. And then as you use higher resolutions, say the 3km one, then you will see that more details of the terrain represented. And then near the ground, the terrain following vertical layers also contains information about the terrain like this, but going up to upper layers, it becomes very smooth, so-called hybrid way. So this is the information about the vertical layers to use. Last time we talked about the height of the 40th layer. So I shall show you this screen capture. We can actually use just use a spreadsheet to calculate the way MPAS constructs the default layers. And here is the most summarized form, the result. So this is the index of the layer, the 40th layer, okay, not shown here. And then this is the resulting height above ground. And you can make a plotting like this. So for the 40th layer, I've shown you last lecture, you can look up, it is about 15,000 meters above ground level. Okay, so after you have done 3D visualization, you can look up the actual height above ground level with this plotting, or you can visit the spreadsheets, hopefully share with you. Okay, you don't need to go into details of the calculation, and then you can look up just by 40th layer, and then above ground level, it is actual value, and from the calculation, they should match. This is about 15,000 meters. Okay. This is the supplementary information I would like to show.